Okay, we are live on air 2 minutes early, so they can just crop this part out of the video if it becomes a problem. I'll give people a few more minutes to find it up here to raise. And they even have speaker notes. This will work. Everybody's scared of sitting up here in the front row, so I'll just borrow their table. Maybe. Kind of sort.
Everything kosher?
Yep.
Okay, great.
I'm actually streaming on Hangouts right now.
Excellent.
So there's hoops you have to jump through with with turning yourself into a manager of the page and things.
Yes. Okay.
So I'll show you how to do that afterwards.
Thank you. Okay. That'll be great.
So everybody here is here for thinking in Git, right? It said that up on the screen for a few minutes. How many of you have used Git before a little bit, but you're not really that sure what's going on? Carbon, you know what's going on. Okay. How many of you would have used it a lot, done merges, kind of know what you're doing with branching, that kind of confidence? And then how many of you have never used Git before, but you're just interested in learning about it? Awesome. So for those of you who might not know how to explain this as clearly, Git is what we call a distributed version control system. Version control, oh yeah, I should introduce myself. Git is the open source version control system, more or less. There are others, but it is what the kernel uses. Linus Torvalds actually wrote it for use in the kernel. And it is the most widely used, and there are a lot of tools out there to convert other source code management systems repositories into Git ones. I'm Emily Dunham, on Freenode IRC and Portland State IRC and a few other networks. You can email me. I'll have this at the end as well. I have some cards if you want to get in touch with me. So I'm a sysadmin at the OSU Open Source Lab down in Corvallis, and sometimes ops team person at Urban Airship, and general open source advocate. So what we're going to look at today is how to look at software development, which will be total review for those of you comfortable with using version control systems in general, and might be a bit eye-opening if you've been just kind of making it up as you go along. What Git is, how you should learn it, just what kind of questions to ask, where you should ask them to get useful results. And then we're going to get through as many essential concepts as we can before we run out of time. So when you think about software development, it's basically just a bunch of changes. And sometimes those changes happen in groups. So welcome, come on, grab a chair. So you can have changes for a variety of different reasons, and you can have changes for different reasons going on at the same time, kind of in parallel. Like, oh, my boss wants me to fix this login screen, but I also need to optimize this database code. And those changes may chronologically be intermingled, but they're logically very different problems that you're solving right there. So why do we need version control? If you've ever seen this PhD comic, he's like, this is my final paper. Get some changes, final revision 2. Final revision 6, this is the one with the comments. Final revision 8, the comments and the corrections. And you can just imagine that he's got about 30 or 40 files in some folder, and he's just sitting there going, okay, which file is correct? Which of these versions should I work from right now? Which had the change that I wanted in it? So there are a lot of different ways of doing version control. That's the perhaps natural and generally less optimal one in the comic back there. So you have kind of more formal versus impromptu systems, which also relates to the size of team that you're working with. Some systems scale really elegantly, and others you're just like, okay, I have too many files to manage. I'm not changing all of their names. I'll just hope for the best. You have centralized versus decentralized. These are words you'll hear a lot when we're discussing source code management. Centralized means there's one big golden repository out there, and this is the source of truth, and everybody else just works directly with it. If that central repository goes down, you're out of luck. You can't get your code. Nothing can happen. Decentralized is a paradigm where all of the different copies of the code have the information that they need for someone else to copy directly from them, for you to share changes between them. And you can treat it like it's centralized. You can have one server that everybody agrees that they'll push to and pull from, but that single server isn't inherently necessary, and you can keep using it if that single server is gone. There's concurrent version control system versus locking. Concurrent is, let's all just have a copy of the project and all work on it at our own pace and then put these changes together somehow later. Versus locking is, okay, to make sure that nobody has conflicts in a file, only one person can touch this file at a time. You maybe make a copy and delete it from this repository, and you make all of your changes, and then you put it back and stop changing it, which some older systems and older companies tried to use. It's very inefficient if you try to have a workflow that lets you get things done, because as you know, you need to make changes in often 5 or 6 different files or more to get a single logical change into a project.
Or if someone checks it out and goes on vacation for 4 weeks.
Yup. Sounds like a voice of experience. So and then there's modeling diffs versus snapshots. Diffs are like, so I had this file, and then I changed these 3 lines. So I'll just save those 3 lines because they're the only part that was different. Versus a snapshot is, oh, that file changed. I better save a copy of the whole file. So as you can tell, some of those are preferable to others for various use cases. And as you can also tell, I'm biased because I like Git an awful lot. So the goals of distributed version control, which Git is a version of, are you want reliability. That means you put a given file in, you get exactly that same file out again later. And you have a guarantee of that, which surprisingly not all systems can provide. No single point of failure. Any individual laptop can catch on fire, and only that person's recent changes are in jeopardy. You don't have that single central repository go down and then nobody can do any work. And the other important thing is you don't want to have to be connected to the internet in order to push a change to a repository. This may sound really obvious if you're used to working with Git, but if you have to work with Subversion, you can't commit unless you have network access, because a commit is logically both a commit and a push, which if those sound like gibberish, it's okay. I'll explain them all, but we have a very mixed audience in terms of experience right now. So now that we have this picture in our heads of this wonderful, amazing thing that makes collaboration and change management easy, let's look at Git. You've heard some, you'll hear some buzzwords about it. Decentralized, which I just explained to you. Distributed, which means, again, you have it all data assurance, that guarantee that if I commit a given file to Git and then I check that file out again, it'll be the same file. I won't have randomly changed some bits in it. Porcelain versus plumbing. We're only going to talk about porcelain today. These are the commands that you as a user are actually going to use. There's a bunch of back-end stuff in the guts of the program Git itself, and with how it models data and how it stores data, that you can get in and touch them and change things, sometimes fix problems by touching them, but those are the plumbing. It's pretty messy. It's not really meant to be easy to use, if you can call any of Git easy to use. And it is free and open source software under the GPL v2 license. And the tree, you hear about trees. I'm about to tell you all about what trees are. So the way that Git looks at your project, you have a project is a directory and all of its subdirectories and all of the files in it. There are 3 states that any file or directory can be in your Git repository. So it can either be unstaged, which is just Git doesn't know about the changes. I mean, you can figure out that changes have occurred, but none of the changes are being tracked. There's staged, which is telling Git, so the changes in this file are part of a logical change that I'm making. And you can have changes in several files that come together into a single commit, which represents the 3rd status that a file can be in, or a change can be in, which is committed, which means this has become part of the history of the project. It's more or less set in stone now. You can always use the change information to change something back, but you'll always want to keep the history that change ever happened. So basically, a file can be in your working directory, you'll stage it, and then it's in this intermediate staging area, and then you'll commit it, and now it's really part of the repository. And then someone else, once you've committed your file, can check it out, and then it's in their copy of the repository too, and they can make changes to it in their working directory. So how this all works, to set Git up, first you tell it who you are with git config-e or man git config. If you forget to tell it who you are on your system, then it will very politely prompt you when you try to commit. It'll go, here, you should run this command, git config global user.name, and then your name, and user.email, and then your email. Because as we'll see when I talk about blaming and finding who made what change, it's really, really nice to be able to tell. So when was this file changed? When was that line last changed? Who did it? So you can just walk over to their desk or send them an email and go, why did you do that? If their commit message doesn't explain it to you. So you can transfer files around on a network with HTTPS, but I would strongly recommend setting up SSH keys. These are not Git commands. These are just system commands that you should have on a Linux or Unix box. SSH keygen will default to type RSA and 2048 bits. ECDSA keys are shorter. Some would argue that they're less cryptographically secure, but they are shorter and work just fine on GitHub. They don't work on GitLab, and they don't work on GitLite. They don't work on some other Git software. So go with RSA keys. Install Git. If you like graphical user interfaces, you want TK and TCL. There's a nice GUI for visualizing what state your project is in and the way that the different branches have gone, which some people find really helpful. Got a question? People out there, you can come in if you want.
This is thinking in Git.
So if you have a preferred editor, it'll default to Via Vim, but you can set the Git editor environment variable in your shell config, or you can set the editor in your Git config. And then pick a project to work on. So a repository is basically just a database of snapshots. So it's not a snapshot of the whole code, it's a series of changes, but you can think about it as like frames in the movie of your project going by, that each commit is that frame with a little bit of change in it. And you can tell that a directory is a repository by typing git status. Then if that directory or anything above it in your file system is a Git repo, which you can tell if it's a Git repo because there's a .git directory in it, the Git status will tell you something. If it's not a Git repo, then it'll say, this isn't a Git repository when you ask it for its status. And you can have repos within repos. So just because you're in a repo right now doesn't mean that you're not inside of a bigger repo higher up your file system tree. So you can look if there's stuff in .git to see if this current directory is a repository. But it doesn't really care which directory of the repo you're in as long as that's higher in the file system than you. So there's two ways to get a repo. You can either start a new one, or you can copy one that exists that has a bunch of code and stuff in it. To make your own repo, just type git init. That creates the .git directory in the current folder and sets things up for you. To get somebody else's repo, you git clone the git clone URL. If you've seen a project page on GitHub, over at the right, there's a little box with an SSH or HTTP clone URL in it. You just copy that, git clone, paste the URL, hit enter, and it'll make a new directory with that project's name, and then everything will be there in it for you. The repos names will typically be of that form if you're working with GitHub. That would be an SSH one, the git@github.com one. or username at some other site if you're not using GitHub, using your own Git repo. And that's the HTTPS clone form that will always prompt you for username and password. So if you're using GitHub, set up SSH keys and clone via SSH. Otherwise, you're going to be typing your username and password a lot. So now we're in a repo. Let's look around. If you're in an empty repo, git show will fail and be like, you haven't done anything yet. What's going on? If git show fails with, hey, this isn't Git, then you're not in a repository. Otherwise, git show will tell you things about the status of your repo right now. So how do we undo making a repo? You cd up until you're in the top level of the repo, and then you nuke the .git directory. Don't do this if you want to keep your changes. If you erroneously created a repository where it shouldn't be, this is sometimes the right command. But if you want to undo a change, this is not the right command. This is the, oh, I regret ever starting this project. Forget that anything ever happened in it. And unless someone else has a copy, all of your work will be lost. So, staged changes. I mentioned staging changes before with that same picture. The staging area is kind of like backstage, like things are waiting to go into a given commit. And a commit is, as I'll say again, a logical bundle of changes that makes a single logical change, a single change that you describe with people words in your project. Like if I have a bunch of services in a chef configurations repo and I'm removing one, then I'm going to remove it from the cookbooks and I'm going to remove it from a bunch of other files that refer to it. So I'll have changed maybe a dozen files, but that's all the logical change of remove that one service. So you change all those files and then you stage them. You stage them with git add. So git add takes a file from being untracked to being staged, or from being just having random changes in it, and it takes all of the changes at the time that you git add the file, and then adds them to a staging area. So examining stage changes, git status will show you things about them. So changes to be committed, and it tells you very helpfully here how to unstage a file without deleting the file itself. And then it'll tell you if you have any changes that you haven't staged yet. Now, one thing that's important to remember is that when you add a file, it adds the file as it was when you hit the add command. So if I add the file, and then I make some more changes to the file, and then I commit, the changes that I made after adding it aren't going to be in that commit unless I've added it again. So if you want to see what will happen, see what changes will be added, you see what files will be added, you can also git commit with the dry run flag. That won't actually create a commit, it'll just show you what would happen if you did. So again, to undo having staged a change, you remove the cached version of the file. If you want to just reset everything to how it was last time I committed, oops, I really shouldn't have made those changes, you can reset the file to head. That says, oh, I wish I hadn't made changes, I wish I hadn't staged changes, just go back to the last commit. So thinking about snapshots or commits. How am I doing on time? Oh, I'm doing great on time. So a snapshot is like the changes to a file plus pointers to the unchanged parts of files. It's not a diff because a snapshot tracks all files. A diff would only track the files that have changed, but a snapshot will have a reference to every file, even if it's just, no, that was unchanged, point back to the last time it changed. And it's not a duplicate of everything in the repository, because instead of an actual copy of the unchanged files, you will just have a pointer back to them the last time they were changed. So basically, you change your files, and then when you make a new version, so A, B, and C are new here, and then the next version, maybe you change A and B, or A and C, but you don't change B. But that version still knows that file B is there and part of that version. This is just kind of background and philosophy. If this doesn't make perfect sense to you, that's fine. You will still be able to use Git. So this brings us to commits. A commit is a snapshot of the changes that you have staged. So a commit also has some metadata that goes with it. These are the author, which you get from your git config, the date, the committer. So one fun fact about Git is it's meant for a model in which the person who actually merges a change into the project isn't necessarily the same as the person who initially wrote that change. So you track both the name of the person who originally made the change, if you're like, why did you change this file instead of that file? And then the change of the person who merged it into a tree. So if it's like, wait, why did you apply that patch? It broke things. So there's two different people you might need to contact. And it tracks the identities of both of those people. And that makes everything so much easier for you down the road. Bless you. And it tracks the parent commit. So each of these, and this, since each commit knows which commit its parent was, then you have this really nice tree, directed acyclic graph, and this allows you to do operations that combine commits elegantly, and it guarantees certain security properties. I think I go into that later. So making a commit, think of a commit as making like a stop in your time travel. Seriously, if you're at a point where it's like, I'm going to want to come back to right now someday, then commit the project in that, or commit your work in that state. If you're about to start working on a different change and might want to undo back to here, if you're about to start something that you're not sure if it's going to work, if you're just about to change tracks and you've got something finished, that's a point in time that you're going to want to go back to. So that's when you should commit. So the git commit man page. Git man pages will typically be of the form git-command name to get to that particular man page, because there's a complete man page on pretty much every command. So you can pass flags to git commit that will just commit everything, commit all unstaged changes. I wouldn't recommend it. I would recommend intentionally staging which changes you want, especially as you're learning and as you're getting familiar with it. If you had your author configured wrong and you committed, you can update your author information, and then you can reset author. That will rewrite the commit. And as long as no one else has a copy of this commit, it's okay to change it, to rewrite it, to modify it. Every time you change a commit, though, its hash will change. So I'll talk a bit more about hashes later when we talk about security, but basically the hashes are a way of guaranteeing that the version of the project that I have, this tree of commits and changes, is the same as the one that somebody else has. And this has very strong security properties for you. Let's say that we have 2 copies of a repo and everybody clones from the one of them, and that gets hacked, and we don't know if the hacker tried to change anything in the history or not. And yet I had a copy locally. I can attempt to pull from that maybe hacked, maybe not copy, and Git will tell me whether it matches. And if it mismatches, as in somebody tampered with the history by the changes, it'll be like, do you really, really want to do that? Somebody could have tampered with the history and done terrible things. So moral of the story, which I will reiterate later, is it's okay to change commits before anyone else has them, but once they've been distributed to the rest of the world, don't go around changing them, or Git will be like, hey, somebody changed history. This is bad. So you can manually set a date on commits. This is useful. GitHub has this little gamification graph of when you committed, so you can spell things out in the graph if you write a script that makes commits with arbitrary dates on them. You can, sometimes you want empty commits, like if you're testing a continuous integration system that you need to see whether it fires on commit. Git usually won't let you commit with an empty commit. It's like, hey, you should make changes before you commit. I think you forgot to stage something. But if you're like, no, I'm really just testing stuff, you can tell it, allow empty. Once you've committed and you haven't made another commit on top of it, and you're like, oh, I need to change that, you can just amend the most recent commit. That's really useful if you realize you forgot to add a file or you put the wrong thing in the message, any of that. And commits can also be GPG signed if you're into security or into proving your identity or proving the identity of a given tag. So there's a bunch of different ways to look at commits. There's this beautiful GATK that's a GUI for it that will visualize everything, show you the tree. You can click on a commit and see its information, or you can use the command line. Git show will tell you the latest commit, or if you git show and then a hash will tell you about a specific commit. If you want to see a summary of a given range of commits, you can use git log and then that range. And as usual, if you want the manual on it, man space git dash log will tell you all about the cool stuff that you can do with git log. Man git dash show will tell you all about the cool stuff that you can do with git show, and so forth. And this git revisions page with no hyphen in it will tell you all kinds of stuff about the ranges that you're able to specify. So if you want to see the log of commits, there's other operations that you're going to want to do with ranges later on. And being comfortable with specifying ranges is very powerful. And then if you want to see the commits, the most recent commit that's changed each line of a given file, you type git blame and then the file name. And it'll print out every line of the file prefaced with the date, author, and short hash of the commit that changed that line most recently. This is amazing. You're like, oh, this variable used to be something else. Who changed that and why? You git blame, you look at that line, you take the short hash of that commit, and then you git show that commit. And then it'll tell you, oh, I'm changing this variable because it didn't work on such and such a system. And it's like notes from yourself or your teammates telling you exactly what you want to know when you want to know it, if you use it correctly. This is also why you want to have useful commit messages and why you want to have logically grouped commits, because if you have an unrelated change and the message says something else, then whoever git blamed and looked at that commit is just going to be really confused, and they're going to waste a bunch of time. So displaying commits, you can show with one line. There's a manuals page section about pretty formats, which if you want to print them arbitrarily for any reason, if you're making a little viewer that will show you the history of your repo or anything, you have a lot of control over that. If you have GPG signed commits and want to verify that signature, then you can show with the show signature option, and then use your GPG magic to verify that the signer is someone you trust. And then again, git k will show you that, will give you that GUI. If you don't like memorizing commands and you'd rather click on things, that is absolutely an option for you. So undoing making a commit. Git revert and then the hash of the commit that you want to revert. So the really cool thing about revert is that it doesn't go back and actually undo it. It says, I'm going to take those changes that were made way back in time, or way back in time, I should mirror myself so that I'm on a timeline that makes sense to you, I'm going to go find the changes that were made in that commit. I'm going to make the opposite of those changes, and then I'm going to make a new commit of it. This is called a revert commit. You might be thinking, oh, that's pretty lame. I don't want everybody to know that I messed up. But reversibility is so important. If you inadvertently reverted the wrong commit, if your revert accidentally changed some files and it turns out it shouldn't have because the previous commit wasn't logically grouped well enough, then you want to be able to see what changed and why. And this allows you also to change the commits to put a message for the revert commit saying why you did it. So when somebody goes back, looks at the history, goes, why did that happen? There's actually a note to them saying, oh, this is because of such and such a ticket. And that is just way better than any brief happiness you might get from thinking, oh, I've hidden this mistake and now people will think I'm smarter or something. No, don't worry about it. So now we've got staging changes, we've got commits, and a repository is more or less just a big long change of commits. Now we're going to talk about remotes briefly. So remember when I talked about getting a repo? You can either init your own repo or you can clone somebody else's. A remote is a different repo that shares history with your current one. So you'll often see them drawn as this graph. Let's see, maybe blow it up for you. You'll often see this graph where you have arrows pointing down to a first commit, and then someone branches and makes some more commits and then merges back in. I'll talk about branching and merging in a minute. But everybody started with that same first commit, and that's what makes them remotes of each other rather than just totally unrelated repos. There we go. So you can add remotes, and the remotes can have names. This is really useful when you're working with a bunch of different people on the same project. And it's like, oh, I need to pull in Lucy's changes from Lucy's machine, and now I need to pull in Jordan's changes from Jordan's machine if you're using it as truly distributed version control. So the Get Remote Man page will tell you all of this again, but you just add a remote and you give it a name and you give it a URL. One trick, don't name a remote master. You're like, oh, this guy is such a code master, I should name it that. Don't do it, because master is your master branch and Git will get confused. Other than that, though, you can name it anything you want. Yeah, Jordan? The default remote name is origin. So if I clone from somebody else, that place that I cloned it from will just be added as a remote automatically with origin as its name. And then when I'm not going to talk about pushing yet, I have slides for it. So examining remotes, git config-e is edit my git config, and it will show you a list of all of the remotes as well as your other local git settings. The global git config is where you have like your name and your email and stuff. You rarely need to, and your editor preference, you rarely need to worry about the global git config. You usually care about the local one because it applies to your current repository. Or you can tell Git, show me the remote by that name. Tell me where its URL is. So, like, here's how my Git config looks for a repo called Monty Language. I have origin, which is the Monty Language project's GitHub, and I have my GitHub with my own copy of the repository. So if I push to origin, my changes will go to there if I have permission. And if I say git push ed, then it will go to the my copy because that's its name. The fetch is just when you pull, what do you care about getting? By default, it will basically say everything. You can control it so that it doesn't fetch everything. If, let's say, there's some branch that has a bunch of really big images in it or something and you don't want to pull all that data. So undoing adding a remote, if you prefer a text editor, then just git config-e and just remove the lines that apply to that remote, and now it's gone. Or you can use the git remote commands to either rename or remove it. And if you rename it in your git config just with your text editor, it will start responding to that new name seamlessly. So also, another concept is tags. Tags are kind of like a commit. They're just a marker. They're not file changes, but there's some metadata that goes with a given commit and points at it. Some projects use them extensively to mark their version numbers, to mark their release names. Other projects don't use them at all. But things to note are that branch names are tags, and head is a tag, and head is wherever you're currently working. So if you want to add tags, you check the man page, and then you git tag, and you give it a message, and then you give it a name. So you can check out a tag, and you will get the commit that was tagged with it. So many projects, you'll like check out the commit tagged version 1.0, and then you'll get the repository in the exact state that it was in when somebody applied the, hey guys, this is version 1.0 tag. If you pass -s or -u with your key ID, you can GPG sign a tag. again, if you care about it, if you want to be really secure and make sure that people who trust you can verify that it was you who pushed that. So examining tags, get tag will list all of the available tags. You can regex in the tag list if you want to find a given tag, and then you can check out a tag by name and you'll get the repository right at that state. Undoing tags, just -D to delete them, and then to remove a tag from a remote repository, you push to the remote name and then to :refs tags tag name. This lives deep in man-get tag or man-get push, or you can look at my slides if you've forgotten that. It's the kind of thing that very few people know off the top of their head. You usually have to look it up if you're in the position of needing to delete a tag. So, no, yeah, Corbin.
So when I delete a tag, does it delete the tag for everyone else?
So, won't they have to force pull? I don't actually know that one off the top of my head. What does it do?
They will have to manually delete it when they're on repo.
Okay. So if you delete a tag at the master repo, it doesn't forcibly delete it for anybody else. They would have to locally delete it. So they could do that if they wanted to. If they have a tag sitting around that's no longer used, it's probably not going to hurt anybody. So branches. Branch names are a lot like tags. A branch name is a kind of auto-generated tag that points at the head of a branch. And they're just kind of parallel paths of development. Like, remember when I said at the beginning, oh, maybe my boss wants me to fix part of the user interface, but I want to fix this thing about a database query? You can work on those totally logically unrelated change sets in parallel on the same repository by working on them on separate branches. So a branch has a name and is a tag that points to something. We've got a couple chairs in here if you'd like to sit down. There's also a couple chairs up here. I kind of stole the front table. You can take one of those chairs if you'd like to sit. So the master branch is the one that you have by default when you either create or clone a repo. And then to create a new branch, you use get checkout. You pass it the B flag to make a branch, or you just get checkout and then the name of a branch if it already exists. You use checkout when you're switching between branches because, oh, I've got to work on that front end stuff. Okay, now I've got to work on that database stuff. And then if you just type get branch with no arguments, it'll tell you all of the branches you have available. Also, they tab complete. It's pretty cool. So if you want to push a branch rather than just pushing to master, you tell it get push and then the name of the remote you're pushing to, and then the name of the branch that you're pushing to. So again, examining branches. GitHub has a really nice graphs feature in its user interface that'll visualize graphs or visualize branches for you. GITK can also try to visualize branches for you. Or you can just have it print a list and then work with the command line. So if you git show the branch name, it'll show you the commits on the branch, just like git show with no arguments shows you the commits on the current branch. So undoing branching, with a -d, it will delete it only if all of your changes were merged into some other branch or into the upstream. If you're like, no, I don't want those changes, just throw them away, with a capital D, we'll delete it forcibly. And then to delete a remote branch, we have the same get push remote name and then the colon branch syntax, colon branch name this time, rather than the colon refs heads, refs tags that we saw for deleting tags. So then you can pull specifying a branch name to get the changes from that branch at the given remote. And we're just getting more and more branches. What do we do with them? Does the project just fork? You can merge them back together. and you'll end up with the changes from the branch that you merged as well. So now that C7 commit will have the changes we'll have C6, C5, C4, C3, C2, and so forth. It'll have all the changes up to that point. So merge conflicts are a thing that happen, unfortunately. Git's actually really smart about merging files together. It tries something like 8 different strategies, but sometimes it still comes down to a judgment call. Like, let's say that Mark and I are working on the same repository, and I change the title of the website to be Emily's awesome site, and Mark changes the title to be Mark's awesome site. Git has no way of knowing which of those is correct. So it'll say, you have a merge conflict when we both try to push to the same repository. And the way the merge conflict will look in the file is a bunch of chevrons to the left, and then the tag that you're on, like head, your current branch, and then the content that was in that branch, and then a line of equal signs, the content that conflicted with it, and then a bunch of chevrons to the right, and then the name of the branch that the second set of content was in. Typically, what you want to do is you look at it, you think about it, you decide what's correct, and then you usually just delete all of this and put in what was correct. Sometimes you delete all but one of these lines, and then you edit that line to work. It really depends on the situation, because merge conflicts are inherently those places where Git was like, I need your human knowledge here. So once you've resolved your conflict, you delete the line of chevrons, you delete the equal signs, and you make it correct in there, and then you git add the file, and you git commit, and it will have a default commit message for you saying, merging such and such into the other thing, we had conflicts in these files, and you can add extra information to that commit about the changes that you made, why you picked that change, and so forth. So use git status before you commit to make sure that you have all of the changes that had conflicts in them. And there's a graphical option called git merge tool if manually searching your files for either the chevrons or the equal signs doesn't work for you, or just doesn't make sense to you, I mean. So examining merges, if you diff the commit before to the merge commit, that will tell you everything that changed in the merge. You can use the git log with ... and then a branch name to show you what's there but not here. You can git diff the other branch, and it will, or git diff ... other branch, and it will tell you what are the file differences that would change. Or again, you can GITK and pass it that argument, and it'll pop up a nice graphical window with things that you can click on to examine it. Yeah.
What's the difference between double dot and triple dot? I've never understood that.
I don't know why there is a difference there. I just know that when I look it up in the man pages and ask git log how to do it, it says double dot, and ask git diff how to do it, it says triple dot. I don't know the history there.
Okay.
So undoing a merge, if you're partway through a merge, and you're like, oh, this is terrible, I should not have done that, just get me out of here, git merge abort, and then you git reset with telling it to keep that last commit, keep the last good commit. And this gets you out of a merge, more or less. You might have unstaged changes, you might have to check out those changes at a commit on the branch that you want to end up with, but merge abort is the way to get out of there. So we have staged files, we've committed the files, we can branch, and then we can merge branches back together to get changes from one place to another. Now, there are ways of changing history. A git rebase goes back in time and reorders the commits, or combines some commits, or breaks a commit apart into lots of pieces. And sometimes this is a good idea, but a lot of the time it's a really bad idea. Because remember that part about security and history, and how if your history and the other guy's history match, then your hashes match, and so you can just pull from his repo and he can pull from your repo, and everybody's happy. As soon as you start rewriting history, the hashes are going to change because they need to. What if a bad guy rewrote history? You need to be warned that things have changed. And then people are going to have to tell Git, no, really, I know that this could be really malicious activity that could break everything, pull anyway. That's called a force pull. People don't like doing those. If you rebase and change history on a big project and then ask someone to pull from your branch, they will probably laugh at you. People don't like force pulling. Every once in a while, it'll be necessary. Like if you added some really big files that are bloating your repository and it's taking too long to download for everybody, then they might be okay with it. But generally, a good rule of thumb, unless you know for certain that you have to do it a different way, is don't change history that other people have. Only change history that's local to you before you've pushed to make you look really smart. Because you can make a bunch of commits and then change them around, make it look like there was just one commit where you did everything perfectly and never made any mistakes, and then push that commit. That's great. But if you push a bunch of changes with mistakes in them, and then somebody else pulls, and then you try to make it into one commit that makes you look perfect, it's just going to annoy everyone. So with that disclaimer out of the way, you Git rebase -I for interactive rebase, and you give it a range of commits. One such commit range would be head ~4. This is like, oh, I put those last 4 commits in an order that really didn't make sense. This is especially useful if you want to amend a commit. The git commit amend option is usually the easiest way of rewriting a commit. And then you can just, I'm like, oh, 3 commits ago, I did something stupid and I need to change that message. And I need to add a file. I'm just going to rebase it so that that commit happened last and then amend that commit. Now, as long as all these changes are local, everything's okay, because you're not going to change anybody else's history. The other really frequent case for rebase is, oh, I did a bunch of work today, and now I can't push because I'm mismatched from origin. I wish I'd pulled this morning. Git pull with a _ rebase will unroll all of the commits that you haven't pushed, and then apply all of the commits that the remote had that you didn't, and then put your commits back with the same date and the same timestamp and the same committer information and the same changes. Everything will be the same in your commits except for the hash. And that SHA hash is the way that we can affirm Git security properties and match that, oh yeah, this is the same tree as that other tree. So again, this is why rebasing is bad on history that other people have. So for instance, so when you rebase interactively, now you're in a rebase. It'll say we're rebasing that range of commits onto a given commit. You preface each line with the letter or word that symbolizes what you want to do with it. It's really self-explanatory. It's friendly and helpful. If all you actually wanted to do was reword one commit message, you didn't even have to rebase and then amend. You can just reword it in the rebase. And then to undo a rebase, you can reset hard to the original head tag, and that will more or less put things back how they were before you started. Because Git automatically created that tag for you when you started the rebase, assuming there was a chance you might have wanted to go back. And, oh no, I'm stuck in a broken rebase. Get me out of here. You can abort a rebase just like you can abort a merge. So it is 10 till. Who has questions? I also have a couple of slides on doing GitHub things. If you want to get involved with a project on GitHub, we could rush through them. See how your next talk is at 11, so I won't fault anybody for heading out right now. But questions, comments, or GitHub? Got any hard questions for me yet, Lucy? Okay, I'm sorry, that amount of information and slides full of commands kind of makes you feel like your brain is melting out your ears if you didn't know it before. It's a perfectly normal, common feeling. It happens to everybody when they start with Git. I just told you the stuff that I learned in probably 6 months. So it's normal for it to not make total sense right now. These slides, I will put them up linked from Lanyard, which the SeaGL site links to, because I don't expect you to have written down or remembered everything that they said, and they also have a few speaker notes in them as well. So, yeah, Corbin?
Help, I accidentally tried that -D get branch delete command that you said that I should only use if I'm really sure I want to delete a branch, but I did it anyway.
Did you use it? Okay, it's question 0. Were you really sure you wanted to delete the branch?
I thought I was, but then I changed my mind.
So I'm going to refer you to a psychologist or mental health professional to help you with that. Git did exactly what it should have.
It tells me that it says that the branch used to be called something D4E0C74.
You might be able to check that out. You could try that. You could dig in the man pages of Git branch and see if it tells you how to get it back.
You can create a new branch from that pattern.
Yes, all you have to do is check our video.
Okay, since Jordan talks really quietly, the answer to that is all you have to do is check it out and then apply that tag. So for those of you who are going to a next talk in here, or comatose because I melted your brains, or any of this, GitHub is a site that will give you, that will host your repositories. It's great if you want to back up your code. It's great if you want to work with other projects that are hosted on GitHub. GitHub is not Git. GitHub is a centralized version of Git, and this works really well for some people. There is a talk linked in my slides on why GitHub is not exactly Git. You have different types of clones. It brings in a formalized paradigm of forking a repo. There is a button that says fork on it. This makes you a clone of the repo that you have full permissions on and you're an owner of. GitHub also adds the concept of a pull request. These didn't used to exist. Pull request, you have a branch, and you're like, you don't have permissions on the main repo. You hit the pull request button from your fork, and then you can leave them a little note about why you want your changes merged. The annoying things about GitHub, if you make a branch and then you make a pull request and then you push more commits to that branch, those commits will be added to the pull request. This can be really good or really bad. You just need to know that it happens. So once you check out a branch specifically for making that PR, you push the stuff for the PR to it, and then you go do your work on some other branch. Is the way around that. They add an access control system on top with group management and stuff. They have help docs on it. And they don't require a project license. You should license your projects. If you want your project to be free software, it is not free software until you have added a license file. A few popular licenses, GPL, Apache 2, the MIT license, the BSD license are a few of the big ones. There are a few sites out there on which license should I use. Sometimes for artistic stuff, you can license it. Creative Commons makes more sense than licensing it with a software license. But put a license file in. Otherwise, other people can't legally use your code. GitHub adds wikis. It has a gist feature, which is kind of nice. They're like a single file with change history, just for like, it's kind of like Pastebin, but with extra features. They have issue trackers. They have cool graphs. If you look at the side, it's like graphs, and it tells you all about contributors and what time of day they commit and when they've committed and stuff. It'll automatically display whatever's in the README on the main page of the repo. So give your project a README. And it builds in some continuous integration stuff, which you can make fire when you commit to a repo. And now you have 8 minutes to get to your next talk. So thank you all very much for being here. Hope you learned something.
Pointers on switching to centralized version of the